Good morning, guys. Happy Monday. Hopefully, you had a good weekend. Today, we're going to be learning a little bit more about gravity, which is a force. We've been talking all about forces and how they affect us. Gravity is a force that acts on us even without touching us. Usually, we think of forces as two things that are touching and pushing or pulling each other. This is a force that works without two things being in contact. Now, before we dive into this today, let's talk about that reading assignment that you had last week. I've given you several days to get it done, tried to give you a lot of time. However, I know that those of you who were trying to do the modified assignment, so if I gave you the sort of shortened assignment, I know we had some trouble with that because I think I didn't set up the file correctly. So I'm going to change for this one how I want you to do it, and next time I'll try and have it set up correctly. We'll try something different. But for this one, let's just have those of you doing the modified assignment, please do the odd numbered questions. So forget that modified one, unless you figured out how to do it, but I think it was locked or something. Just go to the regular assignment and just do the odd numbered question. So that'll cut the assignment in half for you. Again, that's only for people who I have actually sent an email to saying you can do the modified assignment. Everybody else should still be doing the normal regular assignment and turning it in. Yeah, I've given you up until tomorrow to do that. If you need a little extra time, because of the modified thing not working, that's fine as well. But get that done because it will be going on your grade here soon. Well, today is notes on gravity. I'm going to talk about it a bit. I recommend that you maybe write the bullet points down in your notes. You can pause the video at any time and write the stuff down. I will also be posting this video and just the slides up on our Google Classroom account. So you should be able to find these there. But of course, all this material you'll see on quizzes. Make sure you rewatch it when you take a quiz. Maybe watch it a couple times to get all the information down. That's one of the nice things about these videos is you can rewatch. So let's talk about gravity. Gravity is a crazy thing. One thing that interests me about gravity is that it's everywhere. We know it's there. We know it pulls things down, but we don't really know that much about why it's there. Why do objects pull together? Why does the earth pull you down? We have some theories. But really, it's kind of, in a lot of ways, it's a mystery. We have ideas of what we think is happening, but we don't really know for sure in a lot of ways. We know that it does pull you down. We can measure how fast it pulls you down and how strong the gravity is. But why is there gravity? That's a tricky question. Another day, we'll talk about some of the theories about why there is gravity, but we won't get into that today. So first of all, and you will want to write this in your notes, so pause here if you need to, or just come back to the slides that I have posted on Google Classroom. But gravity is a force of attraction, meaning it's pulling things together. And as you can see here, it attracts any two objects. If you have two objects, there is a gravitational force pulling them together. It doesn't matter what the two objects are. If you have two small rocks, they have a little gravitational force between them. I have a gravitational force between me and the computer. It's there. It's not a lot, but there's a gravitational force there. Some things have more of a gravitational force than others. Some forces are weak. That's why, as you know, you go to the moon, well, you're going to be lighter on the moon because it has less gravity. Well, the reason the gravity changes, it depends on two things. First, as you can see here, it depends on the masses of the object. The more massive or the bigger and heavier something is, it's going to have more gravity that it pulls with. That's why the Earth, for example, pulls on you stronger than the moon. You weigh more on the Earth than you do on the moon. It's about 6 times more on the Earth. That's because the Earth is bigger. If you look at the size of them, here's the Earth, here's the moon. Can you see that? Not very well. You can try it with a darker color. Here's the Earth. Here's the moon. You sort of see those. Okay. Earth is bigger. That's not exactly to scale, but the Earth is bigger, has more gravity, has more mass. The moon is smaller, so it has less gravity because it has less mass. Okay? So the bigger something is, the more mass it has, the more gravity it's going to pull with. If you go to Jupiter, you're going to weigh even more than you do on Earth. In fact, you're going to be so heavy you aren't even going to be able to stand up. Your leg muscles won't be able to keep you up in the air because gravity would be so much stronger there because Jupiter is so much bigger. So that's the first thing. Now, the second thing that affects how much gravity there is how close the objects are. If you take two objects and you get them further and further apart, the gravity that is pulling on the objects gets less and less. So if you are on the Earth, it's not going to work. If you have any markers that will show up. If you are here on the Earth, there's a certain amount of gravity there. If you go flying off the Earth, well, the further you get, the gravitational pull gets weaker and weaker the further away you get from the Earth. Okay? So the two things you need to know that change how much gravity there is how massive it is. The bigger it is, the more gravity, and how close they are. The closer together objects are, the more gravity there is as well. Let's just remember really quick here. And again, you would want to write this down or at least review it. There's a difference between mass and weight. Mass is how much matter is in an object, right? How much stuff is in there. We talked about this a long time ago. How many atoms and molecules are in something. And that's what creates more gravity. The more mass there is. Weight, on the other hand, is how strongly gravity is pulling on an object. There is a difference here. So more mass equals more gravity. And that also means you're going to weigh more. Remember that if you move an object to a place where gravity is different, the mass doesn't change. You still have the same amount of stuff in you, but you will weigh a different amount. If you go to the moon, we talked about this a long time ago. If you go to the moon, you weigh less because there's less gravity pulling on you, but your mass hasn't changed, right? You still have the same number of atoms and molecules in you. So just remember that as we have this discussion. More mass, more stuff in there means there's more gravitational force. So if the amount of gravity depends on mass and the distance between the objects, well, you should know that gravity is everywhere. Everything that has mass has gravity. So the Earth, of course, has gravity. A book has gravity. You even have gravity. And even something as small as an ant or even smaller has gravity. Everything has gravity. The more mass, the more gravity there is. So you don't have a lot of gravity, but you do have some. So that leads us to an interesting question. What happens when you jump into the air? These kids jumping there. Well, when you jump, this is fascinating. Here's the Earth, and you're going to be super large here, just so we can see you. Here's you. When you jump, we know that you go up into the air, and of course, gravity pulls you back down. Well, yeah, we know that. But remember that because you have mass, you also pull on the Earth, and this is where it gets weird. So when you jump into the air, gravity pulls you back down. But you also pull the Earth up to you. Now, isn't that crazy? Not very much. Now, we're talking like 1,000th of an atom of distance, right? I mean, very, very small amount, incredibly small to where we really say it's pretty much zero. But remember that for every action, there's an equal and opposite reaction. So when you jump, what happens is you go up in the air, maybe 2 feet, 3 feet, and the earth gets pushed away from you like 1,000th of an atom. So you go up and the earth actually goes down just a tiny, tiny, tiny bit. Not anything you could measure. But you push the earth away. So you're really doing this. You're going up and the earth is going down, but it's really just you're going up way more than the earth is going down. And then when you're in the air, the earth pulls you back down, but you also pull the earth back up. So you end up back in the same place you started, right? But yeah, you theoretically, you actually pull on the earth just a tiny, tiny bit. So small you can't measure it, but you have gravity, so you pull on the earth. Your mass is small, so you don't pull that much, but you do. Isn't that crazy? Okay, well, we said that the more mass something has, the more mass something has, the stronger the gravity. Okay, so here's another question. So the Earth is billions of times more massive than the Earth. So therefore, it has billions of times more gravity. Way more gravity than the Earth. So how come, as we're standing here on the Earth and the sun has billions of times more gravity? So here we are. We'll have the sun over here and the Earth over here. And you are standing here on the Earth. So how come, with this having so much more gravity, it doesn't just pull you right off the Earth and pull you right into the sun and burn you up? It has way more mass, way more gravity. So why doesn't it just pull you right off? Billions of times gravity than the Earth, but you are so close to the Earth that its gravity over stronger on you than the sun's. So no matter how far apart two objects are, there's always gravity between you and the stars out there. They're pulling on you. It's very weak because they're away. Further apart, the less attraction there is. So yeah, lots of mass, but it's so far compared to the Earth that it doesn't. Yeah. What if you were in a spaceship? Halfway, I tried to make this halfway. Let's assume exactly halfway between the Earth and the sun. What's going to happen to you? Which way are you going to be pulled? Or are you just going to stay right where you are? So in our diagram here, you're here exactly halfway between the Earth and the sun. What's going to happen? Are you going to be pulled to the Earth? Are you going to be pulled to the sun? Or since you're exactly halfway, are you just going to sit there? What do you think? Think about it for a second. Well, if the distance is equal, right? You're the same distance here as same distance from